everybody, it's Hazel and welcome back to ACE Tutoring. Welcome back to another ACE Tutoring video. I am so excited to today be doing a video on types of nuclear reactions that you can have when you're studying nuclear chemistry. So in every unit of chemistry, you should study nuclear chemistry, not every unit, but in every type of chemistry. So whether you're doing high school chemistry, AP Chem, or college chem, there will always be some unit on nuclear chemistry. So it's really, really important to be prepared and to have some sort of basis of knowledge for the different types of nuclear radiation that exist in nature so that you can be ready as you move into the unit. So the first type of nuclear radiation, well actually, I feel like a good way to start is to give a good definition of what nuclear radiation is. Nuclear radiation is basically when a radioactive nucleus is converted to a more stable nucleus by emitting a type of nuclear radiation through reactions. And I actually talk about reactions in my next video about nuclear reactions. So there's a video for that and it will be in the playlist, the chemistry playlist, or linked in the corner somewhere. But yeah, nuclear radiation is just the type of particle that's emitted during a nuclear reaction in which a radioactive nucleus is being converted into a stable nucleus. So the four types of nuclear radiation that exist are the alpha particle, the beta particle, the gamma ray, and the positron emission. And actually I'm going to switch these two, the order of these two, since the positron emission and the beta particle are actually super duper similar, so it's good to talk about them next to each other. So let's start with the alpha particle. The alpha particle can be written as alpha particle or with the Greek symbol A, which kind of looks like a circle with a really large A, like a really large sweeping line to the side of it. And it is a high energy particle that is emitted from a radioactive nucleus. It contains 2 protons and 2 neutrons, okay? This means that it also contains 2 electrons, technically. It is represented as a helium atom. So you can often see it be written as an alpha particle, the Greek letter A, or it might be written like this. As a helium molecule. And that's because helium is the molecule on the periodic table, or the element on the periodic table that has has an atomic number of 2, so 2 protons. However, because it's got 2 protons and 2 neutrons, the mass number is 4. Remember when we're writing isotopes that the mass number is the number that goes at the top and the atomic number goes at the bottom. So this is the mass number and this right there is the atomic number. So yeah, on the periodic table, helium is the element with the atomic number of 2. So that's why we write it as a helium atom. However, this helium atom, this specific isotope, is an alpha particle. So it's got 2 protons and 2 neutrons. So we write it as a helium atom with a mass number of 4 and an atomic number of 2. The next one is a beta particle, which can be written as a B with a little bit of a line at the end. And it is a high energy electron, so it's got a negative charge, and it is emitted from a radioactive nucleus during a nuclear reaction. It's formed when a neutron converts to a proton and an electron. So when a neutron splits into a proton and an electron, the electron that is formed is the beta particle. It has no mass, so it has no mass number, but it's got an atomic number of -1, giving it a charge of -1. So it has no mass, but it's got a atomic number of -1, and it can be represented like this. The E meaning electron, right? obviously this here is the mass number, so no mass. But it has a charge of -1, as you can see represented in its atomic number. Perfect. Then after that, we have the positron emission, which can be represented as a beta plus. Beta plus. And it's basically the, I don't know how to say this, the opposite of a beta particle. So it's like the antiparticle to the beta particle. And it can be represented as beta plus or as an E as well, just like the beta particle. And it's the antiparticle because it's got a charge of a +1, where the beta particle has a charge of -1. It also has no mass, but its atomic number is +1. So it's got a positive charge, and it can be represented using beta plus. So it's like positive beta. That's one way to think about it. And then your final one is a gamma ray, which can be represented as like a Y. Y, like this. That's the gamma ray, and it is a high energy form of radiation, and it has no mass and no charge. So its mass number and atomic number are 0. Its mass number is 0, and its atomic number is 0, so it does not have any charge. All right, so these are the 4 types of nuclear radiation that exist, and it's literally just these 4 types. And these are the products that are emitted from nuclear reactions, which, like I said, I have a video on nuclear reactions, so if you don't know what I'm talking about, view that video on nuclear reactions. But this is just a really good introduction to the 4 types of particles that you will see as you work through your nuclear chemistry unit. As always, if you have questions, put them in the comments below and someone from our team will try to answer them. Thank you so much for watching this video, and I'll see you with another ACE Explains video. Bye everyone.